In this presentation, I am going to explain associative memory network. These networks are inspired by human memory. Now let us move to the next slide to see the action plan. So in this section, first we will see what associative memory networks are. Then we will discuss auto-associative memory with its architecture, training and testing. After that, we will study hetero-associative memory with its architecture, training and testing algorithm. Now let us go to the next slide to understand auto-associative memory network. Associative memory network works based on pattern association. That means they can store different pattern. When an input is given, the network produces stored pattern that best match the input. These memories are also called content addressable memory or CAM. Next we learn about auto-associative memory. Auto-associative memory is the type of associative memory network. In this network, the input pattern and output patterns are same. It is mainly used for pattern completion and noise removal. Now let us go to the architecture of auto-associative memory. So see the picture, it is a single layer neural network. The number of input neurons and output neurons are equal. This pattern is used for both training input and target output. Let's see the training algorithm. For training auto-associative memory, use the Hebbian or delta learning rules. First, all weights are initialized to 0. Then for each input vectors, their input and output units are activated. Finally, the weights are updated using the product of input and output values. So now let us go to the understanding the testing process. So during test, the training weights are used. The input vector is applied to the network. The net input for each output neuron is calculated. Then an activation function is applied to get the final output pattern. Next, we can learn about hetero-associative memory. So hetero-associative memory is similar to auto-associative memory, but here the input pattern and output patterns are different. The network stored association between the different patterns. Let's see its architecture. So this slide shows the architecture of hetero-associative memory. It consists of an n input neurons and m output neurons. Here n and m's are not equal. The weight matrix is rectangular and there are no feedback connections. Let's move to seeing the algorithm. So hetero-associative memory also uses Hebbian learning rules. Initially all weights are set to 0. Then input and output neurons are activated using training pattern. Weights are updated using the relation. New weight equal old weight plus input multiplied by output. Let's go to the understand the testing process. In testing, trained weights are applied. The input vector is given to the network. The net input of each output neuron is calculated. After applying the activation function, the association output pattern is obtained. So next we will discuss about iterative auto-associative network. This network repeats the recall process multiple times until output becomes stable. Useful for noisy or incompleted input, allowing the network to coverage to the corrected storage pattern. For example, like trying to remember a partially forgot fact by thinking repeatedly until come fully to mind. Now let's move to the next slide for bidirectional associative memory. So BAMs recalls patterns in both directions, input to output and output to input. So it consists of two layers connected with a weight matrix. Iterative recall the continuous until both layers step For example, seeing a friend face reminds you their name and hearing the name reminds you their face. Next, let's see how BAM operates. So patterns are stored in correlation matrix. Signals move back and forth between layers until both input and output stabilized. Ensure correct recall even from the partial or noisy input. For example, like a two-way street, then name leads to face, leads to name until memory stabilized. Next, we will see BAM stability and storage capacity. So memory becomes stable once the correct pair is recalled. So storage capacity is limited by the size of this smaller layer. So exceeding capacity can cause incorrect or spurious recall. For example, you can remember only a limited number of friends, names and faces, not unlimited. Let's move to half-field network. So half-field networks are auto-associative network. They stored pattern and recall them even with noise or partial input. Uses energy minimization to reach stable memory state. For example, recognizing a friend in crowd room even if partially hidden. Next, see the architecture of discrete half-field network. Here, neurons are fully connected with symmetric weight. No self connections are allowed. Fully connected architecture ensure the network coverage to stable stored pattern. For example, like every memory connected to the every other memory, helping stabilized recall. Next, we will cover training and testing half-field network. So, training uses Hebbian learning rules to store the pattern in weights matrix. So, testing neurons update step by step until stored pattern is recalled. For example, slowly reconstructing a partially seen face in your mind until fully recognized. Next, we will see energy functions are used in half-field network. Energy represent the network is confusions. The network update until energy is minimized, which correspond to stable memory recall. For example, when you are unsure about a fact, your mental confusion is high. Once you recall correctly, your memoral energy is minimized. Let's move to continue half-field network. In this type of half-field network, use continuous value and sigmoid activations. Smooth updates make transition gradual instead of absorb. For example, gradually recalling a memory instant recognized. Your truth your thought flow smoothly. Finally, let's conclude the presentation.